This video is going to be looking at preparing solutions and how to make dilutions. So let's go ahead and get started and talk a little bit about how do we make solutions of different molarities. Creating a solution. The first thing, and probably the most important piece of equipment when we're making a solution, is what's called a volumetric flask. And I have a picture of a volumetric flask there on the screen. The important thing to note about the volumetric flask is a volumetric flask will only be used for a certain volume of a solution. So notice that this is a 100 milliliter volumetric flask. And if you look about halfway up the neck of the flask, you see a line. That line is very specifically measured to be exactly 100 mils. So what we need to do when we're creating a solution is we need to know what is the volume of solution we're trying to create, and we need to find the volumetric flask that matches that. Now, in reality, when you're in a lab, the amount of the solution that you're going to be making is usually going to be somewhere on the realm of every 100 mils or possibly every 50 mils. You're not going to be doing a weird amount like 230. You're going to round up to 250. And you will find a volumetric flask at those regular intervals. So once you have a volumetric flask, it is always good to rinse out your volumetric flask and quickly rinse and clean it with the solvent that you're going to be using. Now, the solvent that we've been talking about a lot is water because it's a universal solvent that we make most solutions with. So you would take a little bit of your deionized water and you would squirt it in there, rinse it out, shake it up, and toss it to make sure that there are no contaminants that are left in that flask. Then what you want to do is you want to use a scale and you want to measure out the exact mass of solute that you need to add. And when you do this, you're usually going to measure it on like a little piece of paper or something like that. And you're going to have that off to the side. Now, before you add that amount of solute to your volumetric flask, you want to add approximately half the amount of water that you need to that volumetric flask. You want some water or some solvent already in there to dissolve the solute that you're about to add. Then what you do is you're going to go ahead and you're going to transfer that solute to your volumetric flask. Now, when you transfer that solute, you're usually going to have a water bottle or a bottle of your solvent off to the side. So you'll kind of create like a little funnel with your paper that you weighted on, and you will squirt that solute into your flask because you want to make sure that you get all of that solute in there. You measured out the exact amount, and that's exactly how much needs to be transferred into that flask. Once you have transferred that amount to the flask, you're going to go ahead and cap it, and you're going to shake it, and you're going to try to get as much of it dissolved as possible. Then the last thing you're going to do is you're going to go ahead and you're going to get that bottle of your solvent, maybe it's a water bottle or a dropper, and you're going to fill it exactly to that line. Now, this is probably one of the most annoying parts of creating a solution because it's so easy if you're not careful to go over that line. And guess what? If you go over that line, you have to make the whole solution again because now it's not the same molarity. You just add more solvent than you needed. And you can't just take it out because guess what? If you take out some of that solvent, you're also taking out some of that solute that you added. So you have to be very careful and make sure that you get the meniscus right on that line. Cap it, and then you're going to invert it a few more times. There you go, and you've made your solution. Dilutions. Dilutions are created by taking the amount of the solution and adding more solvent in it to decrease the molarity. So you might be thinking, okay, so if I want to make a dilution, there's probably some things you need to know. I need to know how much of my original solution do I need to transfer to make my dilution? How much water or solvent should I add to make my dilution? And what will the molarity be of my new dilution? Now, depending on what you know or what you don't know, all these questions are asked by using this equation. M1V1 equals M2V2. So let's go ahead and break apart what each one of these variables represents. M1 is the molarity of your original solution. Your original solution might be called your concentrated solution. It might also be called your stock solution. And the reason why we call it a stock solution is because when you're a chemist or a scientist and you want to buy some solvent, or excuse me, some solution, there's usually one high concentrated solution that you're going to buy. And that concentrated solution is called your stock. That's your main amount, because from a stock, you could dilute it and create any other molarity that you need. You're not going to buy 5 large bottles of different concentrations of a solution when you could buy one of a high concentration and make dilutions to make all your other ones. So we sometimes will call that our stock solution. V1 is the volume that you need of your original solution. So how much of that original solution do I need to take out of that stock in order to make my dilution? M2 is going to be the molarity of your new solution, or your diluted solution. So what is my new concentration? And hopefully you guys realize that that concentration has to be lower. There's no way possible that we could have a concentrated solution and make it more concentrated. We can only make it less concentrated. And then V2 is going to be the volume of your new solution. How much did you need to make of that diluted solution? Maybe it's only going to be 100 milliliters. Maybe you need to make 1 liter. Maybe you need to make 10 liters. But how much are you going to make? So let's go ahead and look at an example that I have on the next page, and we will solve it. So creating a dilution. The other thing that I want to note, and we're actually going to be looking at this next week, this is a very interesting idea called Beer's Law. Here at the very bottom, I have some flasks that are filled with different concentrations of a solution. Notice the color of the solution. Color is a really important indicator of concentration. The darker the color, the more concentrated your solution is. With each dilution you make, the color should predictably get lighter and lighter. But here's my example. Oh, wait, that's not my example. We're creating dilutions. I forgot about this. Okay, so the first thing you want to do is you want to get a volumetric flask for the volume that you want your dilution to be. So this is going to be your V2. You need a volumetric flask for your V2. Just like we did with making a solution, we're going to add about half the volume of water or solvent to that volumetric flask. Using either a graduated cylinder or a pipette, if it's a measured pipette, you're going to measure the volume of your concentrated solution that you need. And you're going to use a pipette and graduated cylinder, and you're going to transfer that to your volumetric flask. Now, if you use a graduated cylinder, you're going to want to rinse out that graduated cylinder with a little bit of your solvent and add that to your flask as well, because you want to make sure that you get all of that into your new dilution. And then fill the volumetric flask the rest of the way with water or solvent, depending on what you're using. Cap it, shake, and mix, and you have your dilution. Now we're going to go ahead and we're going to do an example problem. So when I was talking about a stock solution, what I actually have is an example of a dilution that you might need to make from a stock. So what we have is a picture of some hydrochloric acid. Now the most concentrated solution of hydrochloric acid that you can make is about 11.65 molar. Any more, it's not going to remain in solution. So when I personally buy hydrochloric acid for the classroom and in my back room, I have something that's along the concentration of 11.65 molar, because from there I can make any concentration I want. So I have a stock solution of hydrochloric acid, and it's usually about 11.65 molar. I need to make 1.50 liters of a 1.35 molar solution. How will I make this? Now, the first thing that we need to do is let's identify what each one of our variables actually represents. What variable are we going to assign to these different numbers? M1, or our original molarity, is our stock solution molarity, and that is 11.65 molar. V2 is our next value, which is our 1.50 liter solution. We want to make a 1.5 liter solution of our new dilution. And our new dilution, M2, needs to be 1.35 molar. So what we are solving for is our V1. Our V1 is going to tell us how much of that hydrochloric solution of that stock do I need to add in order to make my dilution. So let's go ahead and flip screens, and let's go ahead and solve this problem. All right, so here's my example that we were just looking at. So let's go ahead and start solving this problem and plugging it into my equation. So really, the most difficult part of this problem we've already done. We have identified our unknowns. So all we need to do is use our equation, isolate our unknown, and solve for it. So let's go ahead and do that. So we have m1 times v1 equals m2 times v2. Now, I am trying to solve for v1. So in order to get v1 by itself, I'm going to divide both sides by m1 to isolate. That cancels out. And so now my new equation becomes v1 equals m2 times v2 divided by m1. So let's go ahead and plug in our variables. So what I have is I'm going to have v1 is equal to m2. Make sure you put it in the right spot. So make sure you don't put like m1 on top. So it's going to be 1.35 molar times 1.50 liters, my final volume that I want of my dilution. And I'm going to divide that by my original molarity, 11.65 molar. So notice that my units of molarity cancel out, and I will have units of a liter, and that will be my volume. So when I solve for this, what I end up getting with three significant figures is 0.174 liters. Now, this is fine to leave it like this, but I'm going to go ahead and take it one step further because we're not normally going to measure out this in liters. It's a lot easier to measure this out in milliliters. So I'm going to go ahead and I'm going to say it's 174 milliliters. So how am I going to make this solution? Well, the first thing I'm going to do is I'm going to need a 1.50 liter volumetric flask. I'm going to fill it halfway up with water. From my concentrated solution of 11.65, I'm going to use a graduated cylinder and I'm going to measure out 174 milliliters exactly. I'm probably going to have to use a very careful pipette to make sure I get exactly that 174, not 73, 75, or something like that. I'm going to go ahead and add that to my volumetric flask that already has some water in there. And I'm going to rinse out my graduated cylinder with a little bit of water, swish that around, and dump that into my volumetric flask to make sure I get all of that acid that might be left over in my graduated cylinder. I'm then going to go ahead and take my water bottle, and I'm going to use that to carefully make sure I add it up to that line in that neck in that volumetric flask. Again, make sure you don't go over. If you go over, you just totally messed up and you have to start all over from scratch. It's a pain in the butt. I have done it so many times in the lab. So carefully, once you get close to that line, add drop by drop to make sure you don't go over. Cap, invert a couple times, make sure it's all mixed, and you've got your dilution. So that is how you make your dilutions, and that is how you solve your dilution problems.